Good morning, student. Uh, this is a JW question, which is asked in the year of 2019. The problem statement is like this: a block of mass 10 kg is kept on a rough inclined plane as shown in figure. So here there is a 10 kg of block which is placed on the inclined plane, which has make an angle of 45 degree, and a force of 3 Newton is applied on the block in a downward direction, and the coefficient of friction between plane and a block is 0.6. What should be the minimum value of P such that block doesn't move downward direction? So here they have asked us to calculate the value of P. So here from the diagram, two forces are acting, means one force is 3 Newton which is acting downwards, which is pulling that block on the inclined plane, as well as this 10 kg of mass is also helps the block moving in a downward direction. So we need to calculate this P value so that the net resultant force acting on the block must be 0. So here this is a mg and this force is mg cos theta, and this is a normal reaction force. So these forces are also taken into consideration so that the resultant of force must be 0. So now I will divide this problem statement in two segments. So here what I will calculate here is sum of horizontal forces that must be equal to 0, and sum of vertical forces that must also be equal to 0, means the total resultant of force must be 0. Then only the block remains at a rest position. So the sum of horizontal forces, here the horizontal forces, one is this one is 3 Newton plus the, because of this 10 kg, here there is a one more force which will act. That force is nothing but this one more force that is acting, mg sin theta. So that I will write mg sin theta minus, see these two forces 3 Newton as well as mg sin theta, they are acting in the same direction, though I have taken it as a plus sign, and opposite to these forces one is minus P and another one is a frictional force, that is Fr. So the Fr is equal to 0. So these are the whole horizontal forces, and that I am equating into 0. So I will rearrange this equation. This 3 Newton plus mg sin theta is equal to P plus frictional force. So 3 Newton mg sin theta P plus this frictional force also depend on this normal reaction force, and we have that formula that frictional force is equal to mu into N. Mu is a coefficient of friction between plane and block, and N is a normal reaction force. Now the sum of the vertical forces must be 0. So vertical forces, one is mg cos theta which is acting downward direction, that I am taking it as a plus, and another one is normal reaction force which is in upward direction, I am taking it as a minus sign, is equal to 0. So mg cos theta is equal to N. So this equation I will take it as a 1 and this equation I will take it as a 2. So put equation 2 in 1. So now this is 3 Newton plus mg, m value is 10, g value I will also take it as a 10, acceleration due to gravity 9.8, approximately I am taking it as a 10, and sin theta here is sin 45 degree, P value we don't know, plus mu value, this mu value is 0.6 they have given, and N value n value I have got here is mg cos theta. So 0.6 mg cos theta. So this is 3. This is 10 into 10 is 100. Sin 45 is 1 by root 2. This is p as it is 0.6, and here m is also 10, and this g is also 10, and cos 45 degree. So 300 divided by root 2 is equal to p plus 0.6 into 100. Again cos 45 is 1 by root 2. Now I will multiply this 0.6 into 100, so I will get answer 60 divided by root 2, and here is 3 divided by root 2. Now I will take a LCM here, root 2, so 3 root 2 plus 100 is equal to p root 2 plus 60 divided by root 2. This root 2 get cancelled, and now this 3 root 2 plus 100 is equal to p root 2 plus 60. So this 3 root 2 I will take it as a 1.4 plus 100, and this is p root 2 plus 60. So 60 I will take here in this side, so 60 will come here, and this is p root 2. So this is 4.2 plus 100 minus 60 is 40. So p root 2. So instead of this taking 1.4, I will take it as I will place as it is, like 3 root 2 only. 3 root 2 plus 100. So 3 root 2. This is plus 40. Now this p is equal to, this is 1.4 is 4.2, and this is 40 p root 2. This becomes 44.2 divided by root 2. P is equal to, so this approximately 31.28, or I will take it as a 32 Newton. So the final answer, see, I have not given the options here. So the options are, the first one is option is 32 Newton, and the second one is 18 Newton, and the third one is 23 Newton, and the fourth one is 25 Newton. As our answer is 44.2 divided by root 2, that is approximately equal to 32 Newton. The option first one is correct. Thank you.